Okay, let's say that we have some Q1 charge in space, and that we bring another one charge near some test charge QP, and what will happen then is that this charge will experience a force. So if both charges are, let's say, positive or negative, the force between them, actually they will repel each other. And if the signs are opposite, let's say this Q1 is positive and QP is negative, the force between them will be attractive. So what we can say then is that somehow charge will modify the space around that charge, and if we bring some other charge, that charge will experience a force. So we can say that electric field is a region of space where an electric charge placed in that space experience a force. Also, we can visually represent the electric field by lines, and if charge is positive, the lines will point from that charge. If charge is negative, the lines will point toward it charge. So now the question is how to mathematically express electric field. Let's say we have some Q1 charge, and on distance r from that charge, what is the strength of this point here? What is the strength of electric field here? So if we have okay, so let's analyze a little more this picture here. So we have a Q1 charge, and around Q1 charge we have electric field, right? And we bring some another test charge QP in that field, and that test charge QP will experience a force. So the strength of that force is proportional to the amount of the test charge, and also is proportional to electric field at this point here. And if we have a charge, a bigger charge, right, the force will bigger. If we have electric field which is the stronger, yeah, right, the force will be stronger. But what is the formula for Coulomb's law? Let's see. So the formula for Coulomb's law is, okay, we have the constant K. We have Q1 charge here and some test charge QP, and divided by r squared, so the distance between the charges, right? But and these forces are equal, right? So let's divide from this this test charge QP, and what we have now is 4 divided by blah blah QP is equal on Q1. And ladies and gentlemen, what we have here is definition of electric field. So this is definition of electric field. This is actually electric field says what will be the force if we bring some charge by amount of Q, and the units are actually newtons per coulomb or volts per meter. So that's it.